yesterday we already learned about how to write a C programming, okay, by using timer 0, okay, for the normal mode method. Okay, now we are going to see, okay, the other programming, okay, which is now we're going to because in the TCCR, okay, we have two settings that you need to set. One is the mode of the timer that you're going to use, and the second one is the prescaler. Either you're going to enable the prescaler or you're going to not use the prescaler. Okay, so now we're going. Okay, so now we're going to see what is prescaler and why we need to use the prescaler. Okay, so in the previous class, okay, or in previous slide, wait here. Okay, so in the previous class or in the previous slide, okay, the size of the time delay is dependent on the two factors. Okay, there are two factors that will determine uh, the size of your time delay. Either it's a shorter or longer. Okay, one of them is the crystal frequency, which is your CPU speed, and the second one is the timer counter register size, which is your TCNT size. Okay, so in timer 0 and timer 2, okay, the size of the TCNT is 8-bit, which is you can count from 0 to 255 only. Okay, so this is for the 8-bit TCNT, while for the 16-bit, which is a timer 1, okay, so this one here, you can count from 0 to 65K plus, okay, 65,000 plus plus. Okay, so this side will determine, okay, the size of the delay that you're going to create. Okay, in order to create a largest delay, okay, since 8-bit is smaller, okay, because the number of ticks that you can count in the TCNT is up to 255, so you can use, okay, instead of using a timer 0 or timer 2, okay, you can opt to use the timer 1, okay, because this is a 60-bit, and the ticks can be from 0 until 65,000, and then you can generate a larger delay. Okay, apart of that, okay, the crystal frequency or the CPU speed also become the main factor to determine the size of your time delay. Okay, which is, okay, if we refer to the equation that we have, okay, first equation is T equal to 1 over F. F is your frequency, and then next is a delay. Okay, so this is a delay that you're going to generate equal to T multiplied by count. Okay, so this count here is coming from this TCNT value. Okay, so let's, okay, this count here. Okay, okay, we fix this count to 255, for example. All right. So since this one here, okay, if you see the frequency, okay, the frequency is proportional to your T time. Okay, if the frequency is bigger, okay, you have a bigger frequency, what happens? Your the period will become low. Okay, become smaller. Okay, when the T is smaller, what happens? If you multiply with count, then the delay you get will be shorter. Okay, if you decrease the f, okay, which is you use a lower f, okay, smaller f, what happens to your t? The t will become bigger. Okay, you have a large t. Okay, and then when this t is calculated with the count, then the delay that you generate will become larger. Okay, so this crystal frequency is one of the factors that will determine, okay, the size of the delay that you're going to generate. Okay, so the largest time delay only achieved by making the TCNT0 equal to 0. Okay, in order to get a largest time delay, okay, what happens is you need to make sure that the TCNT value is 0. Why is that? Okay, so let's look at the water bottle earlier. Okay, for the overflow method, what we did earlier is, okay, in order to generate a delay, okay, you need to put some water inside of this bottle, and then after that the delay will be calculated based on the how many water that you put inside of this bottle, and then after it overflow from this bottle. So this is the delay that will be generated. Okay, so the top of this bottle here. Okay, meanwhile, okay, to make a largest delay, what you're going to do here is, okay, you need to make sure that the initial value of your TCNT, which is your bottle here, is empty. Okay, no need to put any waters. Okay, and then after that, okay, to generate a largest delay, so you put a water inside this bottle, and then this bottle will fill in until it overflow from this what we call here bottle. And what happened here, so this is the delay that you generate. Okay, so this is the largest delay compared to this one. Okay, to make a largest delay, what you going to do? Okay, make sure that you put your TCNT sama dengan kosong, or you empty your water bottle. Okay, so this is how you're going to make a largest time delay. Okay, since the TCNT equal to 0, so what happened to your count? Okay, TCNT equal to FF minus count plus 1. Okay, since this one is a 0, so you can get what is your count equal to FF is 255 plus with 1 you get 256. Okay, the largest time delay that you can generate by using 8-bit is 256 times. Okay, and then you calculate with your T, the period of your Esther frequencies. Okay, so what happened? Okay, even though you make your TCNT equal to 0, and what happened if the delay that will be generated from this value here, okay, is not enough. Okay, for example, you are going to generate a 5-second delay, but even though you empty the water bottle, okay, and put the TCNT equal to 0, the delay that will be generated only 3 seconds. Okay, you cannot generate 5-second delay. So what are you going to do? Okay, so that's where that's where the Prescale option will comes in. Okay, so in order to make a largest delay, okay, which is then you're going to use the Prescale option. Okay, which is this Prescale option is used to increase the delay by reducing the period. Okay, so the Prescale option allows us to divide the instruction clock by a factor of 8 to 1024. Okay, so this is your Prescale. Okay, so this is the Prescale inside Mega 32. Okay, and then so this is the time of clock source that are going to the TCNT, and this is the Prescale option. Okay, that available in Mega 32, and this is the selectors. Okay, by looking at this is actually a 8 to 1 marks. Okay, which is you have 8 inputs, 1 outputs, and 3 selectors. So these 3 selectors here is coming from CS00 until CS02, which is CS00 and CS01 and CS02 is actually from the TCCR register. Okay, so recall back the TCCR register. The TCCR register you have 8 bits. Okay, and then these 2 bits here, bit 6 and bit 3 is used to determine the mode set. Okay, the mode that we are going to use, and then the last 3 bits here. Okay, this is where the CS00, CS01, and CS02 is located. Okay, which is this will determine what is the prescaler that we are going to use. Okay, so this is your Tak nampak ya. So this is a CS02. This is 01 and this is 0, which is at bit 0, bit 1, and bit 2. Okay, 3 and 6 is for mode setting. Okay, so if you put 000 here, what happens? Because this is a multiplexer. Okay, if 000 and then, okay, this 0 here will go as your output. Okay, so what happens? No prescaler. Sorry, stop the timer. If 001 is used, okay, what happened here? Okay, the clock source is coming from, okay, the, what we call here, the frequency, okay, is coming from this clock, okay, which is you no need to do to divide your pres, okay, your f no need to divide it with prescale, which is fp equal to f divided with prescale. Okay, in this case, prescale is 1. Okay, so you get the same f back. Okay, and then when you put 0, 0, 0, 1, 0, so what happened? Now you're going to use the prescale lab 8. After that, 100 is 64, 256, 0124 is, okay, 101. Okay, 110 and 111 is for the count. Okay, to use for the to count an event. Okay, so this is the prescale option available in the ATmega 32. So this prescale is actually used to increase the delay. How to increase the delay? By make this f here smaller. Okay, since this f is smaller, then the period will become bigger, and when you calculate this period with a count, then you will get a large delay. Okay, so this is the what we call here the theory behind the prescale option that available in ATmega 32. Okay, so with no prescale enabled, okay, the crystal oscillator frequency is directly fed into timer 0. Means that if the X step is 8 megahertz, then you need to use the 8 megahertz in order to calculate the period. Okay, but if the prescaler bit is enabled, okay, when you choose a prescaler option, so what you're going to do is we need to divide the clock before it fed into the timer. Okay, so the lower 3 bit from TCCR0, which is bit 0, 1, and 2, will determine what are the prescale that we are going to use. Okay, so for timer 0, okay, we have 4 prescale to choose from, which is 8, 64, 256, and 1024. Okay, so this is the prescale option available in timer 0 in ATmega 32. Okay, so let's look at these examples here. Okay, find the timer clock frequency and its periods for a various AVR-based system with the following crystal frequency. Okay, given a crystal frequency of 8 megahertz, 60 megahertz, and 10 megahertz, now you're going to find out what is the T. Okay, and assume that the prescaler of 64 is used. Okay, so now we have, let's look at the A. Okay, the X-step is 8 megahertz. Okay, you have 8 megahertz. And then prescale is used, which is 64. Okay, and to calculate the period, okay, the formula that you're going to use is T equal to 1 over F. Okay, so now, since this one here, okay, we are going to use a prescale 64. So what you're going to do is first find the frequency after we enable the prescale, which is the FP. Okay, FP equal to F divided by prescale. Okay, so in this case here, external the frequency, okay, the initial frequency is 8 megahertz. Okay, and then divided by 64, then you will get 125 kilohertz. Okay, so you see it, the frequencies now become smaller. Okay, you have 8 megahertz, and now you okay, after you use the prescaler, then it become 1 to 5 kilohertz. Okay, so next, what happens if the f is smaller, then you get the larger, okay, large t. Okay, so since this one is, okay, now after that, okay, you take this value and put inside of this equation. What happened here is, okay, so 1 to 5 kilohertz, then the period that you will get is 8 microseconds. Okay, so what happened? Okay, please find the t without a prescale. Okay, so this is a t without a prescale. So what you're going to do? T without a prescale is you need to divide it by 8 megahertz. Okay, what is the t that you get? Okay, so 1 divided by 8 megahertz. Then the value that we get is 0.125 microseconds. See, the period here is different. Okay, so this is you have a smaller period, but this one you have a large period. Okay, so B. Okay, so before that, before we proceed with B, okay, we assume that we are going to generate a largest delay based on this calculation here. Okay, so since to create a largest delay, so what you're going to do is you need to put your TCNT equal to 0. Okay, so from the TCNT sama dengan FF minus count plus 1. Okay, since TCNT equal to 0, so the count here is equal to 256. Okay, now we're going to find out what are the delay generated by using a prescale 64 and without a prescale enable. Okay, so now delay equal to t multiplied with count. Okay, so for this one here, okay, with a prescaler, okay, the delay that you will generate is t is 8 microsecond darab dengan count is 256, and then you will get 2048 microsecond, which is equivalent to 2.048 millisecond. Okay, so this is after you use a 64 prescaler. Okay, you will generate, okay, the largest time delay that you will generate, okay, is 2.048 millisecond. Okay, but without a prescaler option enabled, so what is the largest delay that you can generate? Okay, so the delay that you can generate without using the prescaler is 0.25, okay, multiply with 256. 0.125 multiply with 256, okay, and then you will get 32 microsecond only. Okay, so see, if you use a prescale enable, you can generate a larger delay, okay, if you compare to not using the prescale option. Okay, now let's look at B. Okay, B you have a 60 megahertz. Okay, similar lah. Okay, so B, okay, Esther sama dengan 16 megahertz and prescale is 64. Okay, so what you're going to do is, okay, we're going to find out what is the FP because we have a prescale 64 here. So 60 megahertz divided by 64. Okay, then you will get 250 kilohertz. Okay, and then from this 250 kilohertz, what you're going to do here is, okay, you get the T. Okay, T sama dengan 1 over 250 kilohertz. Then the period that you will get based on is 4 microseconds. Okay, and then you do the C, which is you use the 10 megahertz for the 10 megahertz. Okay, so you need to divide it with 64, then you will get the frequency after prescaling is 156.2 kilohertz, and then after that you calculate the T and you will get the T is 6.4 microsecond. Okay, so now we go back to this A here. Okay, we already calculate the delay. Okay, one with without a prescaler, and the second one with a prescaler of 64. Okay, assume that you're going to generate a delay of 1 millisecond. Okay, so based on this one here, based on this delay that we already calculate, which one can generate delay of 1 millisecond? Is it without a prescale, or is it with a prescale of 64 based on the 8 megahertz CPU speed? Okay, anyone? Okay, to generate a 1 millisecond, you have a timer 0. CPU speed is 8 megahertz. Okay, so what are you going to do? Are you going to enable the prescale or just use the without a prescale option? Macam mana? Okay, so in this case here, all right, because if you not use the prescaler, if you not use the prescale option, you not enable the prescaler, the largest delay that you can generate is only 32 microsecond. Okay, so which is not enough to generate 1 millisecond. Okay, but if you use a prescale 64, you can generate up to 2.048 millisecond, which is enough to generate 1 millisecond. So in this case, you need to use the 64 prescale, in order to generate 1 millisecond. What about prescaler 8? Can you generate 1 millisecond by using a prescaler 8? Okay, so you just calculate lah. Okay, find out what are the largest delay that you can generate by using the prescaler 8. For example here, so FP sama dengan 8 MHz divided by 8. Okay, you're going to use a prescale 8. Okay, because we have a lot of prescaler to choose from. Okay, and then 8 MHz bahagi 8, and then you get this one is 1 MHz. Okay, and then T is 1 divided by 1 megahertz, then you will get 1 microsecond. And then 1 microsecond multiply with 256, which is the largest time delay you can generate. When you put 0 to your TCNT, the count is 256, multiply with this value, and you will get 256 microsecond, which is also not enough to generate 1 millisecond delay. Okay, so the minimum prescale that you can use here is 64. Okay, of course lah. 256 also you can generate a 1 millisecond as well, and 1024 prescale also can generate 1 millisecond, because the minimum prescale that you can use in order to generate a 1 millisecond is 64. Okay, so this is how you're going to choose the prescale based on the delay that you're going to generate. Okay, so let's look at the next slide. Okay, so find the value for the Tcc R0 if you want to program timer 0 normal mode with a prescaler of 64 using the internal clock for the clock source. Okay, so now you're going to find out what are the settings that you're going to use in order to do these things here. Okay, timer 0, normal mode, prescale 64. Okay, so this one here, you can done it in the TCCR. Okay, since you're going to use the timer 0, so TCCR 0, so now you're going to find out what are the value that you're going to put inside of this code here. Okay, so recall back your TCCR. So this is a TCCR. Okay, so timer 0. So this value here is 0 and 0. What about prescale 64? Okay, prescale 64, you go back to this figure here or this table here, and find out what are the value for the 64. Okay, Prescale 64. 64 is 011. Okay, so this is 011. Okay, is for the Prescale 64. And okay, now you just put 011 inside here, and the rest you just give a 0 lah. Okay, so this is the value that you might put here is 000000011. Okay, now you know that. Okay, okay, so this one here, it is 64, Prescale 64, and this one here is normal one. Okay, so let's look at this part here. Okay, assume that the X-ter is 8 megahertz. Okay, then find the clock period fed into the timer 0 if a Prescale option of 1024 is chosen. Okay, you have a X-ter 8 megahertz, and then you're going to find out what are the period, okay, that will be fed to the timer 0. Okay, and the Prescale of it here is 1024. So what are you going to do? Okay, find out what is the FP, the frequency after you use the Prescaler. Okay, 8 megahertz divided with 1024, and then you will get 7812.5 hertz or 7.8125 kilohertz. And then after that, from here, okay, you calculate the T1 over F, and you will get 0.128 millisecond or 128 microsecond. Okay, betul ke calculation ni? Okay, 1 bagi dengan 7812.5, and then you will get, okay, 128 microsecond. Okay, so let's assume that you're going to generate. Okay, be sure what is the largest time delay we can get using this Prescaler option and timer 0. Okay, so the largest delay that you can generate is by putting 0 to your TCNT. Okay, so since the TCNT is equal to 0, and then this is FF minus count plus 1. Okay, so the count is 256. Okay, and then the delay is T multiplied by count, and then you will get 256 multiplied with 256, and then the largest delay that you can generate here is 32.768 millisecond. Okay, previously I'm asking you, okay, which is it possible to use a 1024 in order to generate 1 millisecond delay? Okay, this one here, yes, 1024 able to generate 1 millisecond delay. Because why? Because the maximum delay that can be generated by using a 1024 Prescaler is 32.768 milliseconds. Okay, so now let's look at these examples here. Okay, now we're going to do programming. Okay, so assuming that the X-ter is 8 megahertz, okay, write a program to generate a square wave of 1 to 5 hertz frequency on pin port B3, use timer 0, normal mode, Prescaler 256. Okay, so given that X-ter 8 megahertz, and then, okay, then we have another frequency here. Okay, square wave, F wave, sama dengan 1 to 5 hertz. And then, what else? Okay, Prescale 256, timer 0, normal mode. Okay, so this is the information that you will get from this question. Okay, so what are you going to do? Okay, so since you have two frequencies here, okay, so don't be confused. Okay, so one frequency for the CPU, the other frequency is for square wave. Okay, satu frekuensi adalah untuk you punya CPU speed, and satu lagi untuk kamu punya square wave. Okay, so you draw the what we call here Atmega 32, and you have a port B3, so this is PB3, and this PB3 will generate a square wave, which is this square wave here have a frequency of 1 to 5 hertz. Okay, so based on this frequency here, you can get the T, the period of your square wave. So this is your T. Okay, the period of your square wave. Okay, so find out what is the T. Okay, 1 to 5 divided by, okay, sorry, 1 divided by 1 to 5. So what is the period that you can get here? Anyone?
8 milliseconds. 8 milliseconds.
8 millisecond.
8 millisecond, eh? Okay, so now the period here is 8 milliseconds. Okay, so since this one here, the period is 8 milliseconds. So what are the time for the logic 1 and logic 0? So this is 4 milliseconds for logic 1 and another 4 milliseconds for logic 0. Okay, so this time here, 4 milliseconds, is actually the delay that you're going to create. Okay, delay yang kamu nak buat. Okay, the delay that you're going to create. Alright, so now after that, okay, by using the equation 1, T equal to 1 over F. Okay, so you're going to find out what is the period for your CPUs. Okay, since this one here, okay, is using 256 prescaler, so you need to find out the prescaler frequency first. Okay, 8 megahertz divided by 256, and then you will get 331.25 kilohertz. Is it true? Betul tak? Okay, so next, after that, after you get this frequency, and then you, okay, put it inside of this equation, and you will get the T, okay, the T clock or the T CPU is 1 over 3. Okay, so you will get, sekejap. Okay, press the calculator. 1 bahagi dengan 31.25 kilo, and then you will get, okay, 32 microsecond. Okay, which is equivalent to 0.032 millisecond. So this is the T from the prescaler or from the CPU speed 8 megahertz with a prescale of 256. Okay, then go to, okay, use the second equation here. Delay equal to T multiplied with count. Okay, since you already have the T, okay, so this is the T. Okay, you just put inside here, and the delay is 4 milliseconds. So you just put here, and then you will get the count equal to, what is the count? Delay 4 milliseconds divided with 0.32 millisecond. How much count did you get? Anyone? Okay, you will get 1 to 5 times. Okay, 125 kali. Okay, then after that, what are you going to do? Then use the formula number 3 or equation number 3, which is Tcnt. Okay, because before we do the programming, okay, we need to load the Tcnt value. Okay, before you load the Tcnt value, you need to calculate what are the value of your Tcnt. So by using this formula here or this equation, you can obtain your Tcnt value. So Tcnt equal to FF minus count. Okay, so the count here is 1 to 5 plus with 1. Okay, so 255 minus 125. 255 minus 125 plus with 1, you will get 131. or you can change it to hexadecimal, which is 08x883. Okay, so 0x83. Okay, so this is the TCNT value. Okay, after you obtain the TCNT value, next what you're going to do? Okay, so next, okay, we do the programming part.
Finish your TCCR.
Yeah. Okay, can you hear me, guys? Boleh dengar tak?
Yes, Doctor.
Yes, Doctor.
Okay, good. Okay, so now after we get the TCNT, then we do the programming. Okay, so I just keep the introduction, to include the what we call here, to include the header files and then to do the initialization of the input-output port, your main program. I just keep that part. Okay, you can do it by yourself. Now I'm going to focus on the what we call here the timer programming. Okay, so let's this one here. Okay, you're going to generate a 4 millisecond delay. So let's use the void, okay, delay for ms. Okay, so this is your delay subroutine's name. Okay, and then open clear bracket and close clear bracket down here. Okay, what is the first step that you're going to use to do in timer programming, normal mode timer programming? First is load the TCNT value. Since this is a timer 0, okay, so we're going to use a TCNT 0 for timer 0. And what would be the value? 83, or you can use the decimal also can, okay, 131. Or you can use the TCNT 0 equal to OX 83. Either one, okay. And then next, this is the step number 1. What is the step number 2? Okay, after you load the TCNT, what you're going to do is you're going to set the TCCR. Okay, so TCCR 0. So what would be the value inside of the TCCR 0? Since this is a normal mode, okay, so normal mode is 0, 0, 0, 0, and 0 here, and 256. Okay, what is the 256 prescale? Anyone can help me? What is the 256? What is the value that I'm going to put here in order to enable 256 prescale? You can refer to the table above. Okay. Okay, Amirul, berapa ya? For 256 prescaler. Okay, so what would be the value that I need to put here? Okay.
256 Doctor. 56. Is it 011?
011? No, 011. Are you sure it's 011?
Yeah, wait.
Okay, where is the... Okay, here. Okay, look, refer to this table.
Okay.
Okay.
100.
Okay, so the value is 100 for 256 prescale.
Okay. 100.
Okay, so 100. Now you know that this is a timer 0. Okay, based on this setting, okay, you know that this is a timer 0, normal mode, and prescale 256. Okay, so this is a normal mode. This is 256 prescaler, and this is timer 0 because you use a TCCR 0. Okay, this is a step number 2. Okay, now you go to step number 3. Okay, step number 3. What are we going to do? Okay, we're going to monitor. What monitor? To monitor what? To monitor the flags. Okay, what flag that we're going to monitor? Is it a TOV flag or OCF flag?
TOV.
Okay, TOV flag. Okay, so we are going to monitor the TOV flag. Why TOV flag? Because we're going, okay, in this program, we use it the normal mode, which is overflow method. So to overflow method, we need to monitor TOV flag, which is the overflow flag. Okay, so write this code here while TIFR and with so I just use the bit shifting TOV0. Okay, so use the TOV0. Why TOV0? Because we use the timer 0. Okay, TIFR and we put 1 to the TOV0, and then is it equal to 0? If yes, what happens? It will keep monitoring. If not, if the TOV0 equal to 1, so what happens here? So next, you're going to stop the timer. How to stop timer? Okay, put 0 to Tcc R. Okay, so this is a stop timer. Okay, after stop timer, next, what are we going to do? Step number 5. Okay, since the overflow occurs and TOV0 equal to 1, so you're going to clear back the TOV so that it becomes 0. Okay, clear the flags. Okay, so TOV0, sorry, not TOV0, TIFR. Okay, so TIFR equal to, put 1 to your TOV0. So this is you clear TOV0 flags. Okay, then you close the curly bracket. Okay, so that's it. Okay, so this is how to, this is the subroutine in order to generate a 4 millisecond delay by using timer 0 with a CPU speed of 8 megahertz and the prescale is 256. Okay, so this is the solution here. Okay, you can see the solution from this slide. Okay, so tadi I just skip this part here. Okay, this part you can do it by your own because we already do it several times, this one. Okay, so now I'm going to focus on this part only. All right, so first load the value. Okay, OX83. And then after that, put the settings for the timer 0, normal mode, prescale 256. So this is the value if you're using the hexadecimal. And after that, monitor the TOV0 flags. Okay, so this is the value for the TOV0 lah. If you don't want to use this value here, you can use this data shifting. Okay, the shifting. Okay, this coding here. Okay, put 1 to your TOV0. So you no need to remember what is the location of your TOV0. All right, and then after that, stop the timer and clear the TOV0. Okay, so as I mentioned yesterday, the things that you're going to change, in order to do the timer programming is this value here and these settings here. Okay, make sure that the setting is correct. And this flags based on the setting that you're going to use. Okay, this one is remain. Line number 4 is remain, and line number 5, this things here. Okay, this value, this flag. Okay, if you use the overflow flags, and then you need to use to clear the overflow flags lah. Okay, TOV flags. If you use the compare mesh and monitor the OCF flag. So here also the OCF flags. Okay, so that is for the timer 0 using a prescaler and normal mode. Any question up until here? Ada soalan tak? Before we proceed to Ctc mode. Okay, the second method for the timer programming, which is a Ctc mode. Any question?
No, doctor.
Okay, if no question, then we go to the Ctc mode. Okay, so this is the Ctc mode. All right, so in the Ctc mode, there is one register that you need to use. Okay, there is another register lah. Okay, you need to include in your programming. That register called Ocr Register. Okay, so this OCR is used in the Ctc mode. So what this OCR do? So this OCR is actually to compare, okay, to compare with the TCNT value. Okay, if the TCNT value equal to OCR value, so what happen? The OCR flag will set or will raise. Okay, so this is how this is the another what we call here another register lah that you need to consider, which is OCR register in order to use compare mesh mode or CTC mode. Okay, so as in the normal mode, in this CTC mode, the timer is incremented with a clock. Okay, similar to the normal mode. Okay, the TCNT value will increase every ticks. Okay, every clocks, but it will count up until the content of the TCNT equal to OCR. Okay, which is when the TCNT value sama dengan OCR value, so what happen? The timer will be clear and the OCR flag will be set or OCR flag will be right. Okay, so this is the figure. Okay, how the OCR, okay, how the CTC mode works. Okay, so you have the TCNT value and this is the time. Okay, so this TCNT value will increase, okay, proportionally with the time, okay, and it is increased. And now you have another register, which is the OCR register. So this OCR register is used to set a threshold. Okay, for example here, okay, you have a bottle. Okay, you're going to generate a 5 millisecond delay. Okay, and then the water flow is actually the flow rate of the water is 100 milliliter per second. So you're going to generate a 5-second delay. So what happens here? You need to set your OCR at 500 milliliter. Okay, because the flow rate is 100 milliliter per second. Okay, so when you put the water inside here, okay, the water will increase until it reach 500 milliliter. Okay, when the OCR value equal to your TCNT, which is the water that you put inside of this bottle here, okay, then when you already generate a 5-second delay, and here the OCR flag will be set. Okay, similar to this one. Okay, you put a threshold here, so this is your OCR. Okay, then the TCNT will increase until it equal to OCR value, and when increase, what happened here? Automatically OCR equal to 1 will be set. Okay, the OCR flag set, and then the TCNT value will be reset and it will do it periodically. Okay, so this is for the CTC mode. Okay, and then now we're going to look how to write a program for the CTC mode. Okay, so we go back to this here. Okay, so now we're going to look at what are the steps needed in order to write program for the CTC mode. Okay, step number 1. Okay, so what you're going to do here is clear TCNT. Okay, make sure that your TCNT is 0. Empty your TCNT. Okay, so this is the step number 1. Okay, because in the water bottle case, okay, we'll empty the water bottle, and after that you put the threshold, okay, the water level, and you put the water, and once the water level reach the threshold, that you already generate the delay. Okay, then step number 2. Okay, what you're going to do here is load the OCR value or set the OCR value. Okay, then step number 3, after you load the OCR value, then we set the TCCR. Okay, do the TCCR settings. Okay, similar to this one here. Okay, in the TCCR, you have two settings here. One is a mode and the other one is Prescale. Step number 4, okay, monitor OCF flags. Okay, so this one here, if OCF flags equal to 0, okay, keep monitor. If OCF equal to 1 or set, so what you're going to do here, exit loop. Number 5, step number 5, after you exit, okay, exit the loop, okay, exit this monitoring loop. So what you're going to do, stop timer. And the last step here, step number 6, is clear the OCF flags. Okay, so this is the step that you need to remember in order to write the Ctc mode timer programming. Okay, so now this one here. Okay, now we're going to see the what we call here these examples, okay, for the Ctc mode timer programming. Okay, so in the following program, okay, we are creating the square wave of 50% duty cycle with an equal portion high and low on the port B pin number 5. Okay, so this is the diagram. Okay, you have a PB5 here. So this PB5 is used to generate a square wave, okay, which is have the same length of logic 1 and logic 0. All right, and then timer 0 is used to generate the time delay. Okay, you're going to analyze the program. Okay, again, okay, so this one here, you just include all the header files, and then, okay, make sure that you declare the subroutine that you're going to use for the delay subroutine. Okay, and then write the main program. So inside of the main program, make sure that you declare all, or you initialize all the input output port that you're going to use. And after that, in the while loop, okay, so this while loop will do this square wave, okay, to generate this square wave based on the toggling function. Okay, so this is a toggling function. All right, and then after that, okay, so in this example here, okay, please make some correction because this is port B pin number 5, so this one is wrong lah. Okay, so make sure that, okay, you make a correction. Okay, so this is a DDRB put 1 to bit number 5, and this also put 1 to bit number 5 because you want to toggle port B pin number 5, not port B pin number 3. Okay, now I'm going to focus on this part here. Okay, so based on what we did earlier, okay, so this is the step that you required in order to do the what we call Ctc mode timer programming. Okay, you see here. Okay, so this is the subroutine of to generate a delay. Okay, this delay above. Okay, step number 1. You see step number 1. What you're going to do here? Okay, you're going to clear the TCNT. Okay, so TCNT 0 equal to 0. So you already clear the TCNT. And then step number 2, OCR 0 equal to 9 means that you load the value 9 to your OCR. So this is the step number 2. And this is step number 3, TCCR 0 equal to OX0 9. Okay, so now let's find out what are the settings that this program do. Okay, so this is TCCR 0. Okay, you have value 0, 9. Okay, so 0, 0, 0, 0, and 9 is 1, 0, 0, 1. Okay, so by looking at this one here, bit 6 and bit 3, which is 0, 1. So now you know that this is a Ctc mode. And what about this last bit here? Okay, the last bit is 0, 0, 0, 1. So you know that this one here, no prescale is used. Okay, So the setting for this one, TCCR0 equal to OX09 is timer using a timer 0 Ctc mode and without prescale. And step number 4, this one, okay, so this step number 4, monitor, okay, Ctc mode, okay, we're going to monitor the OCF flags. Okay, so that's why we monitor this. Sorry, okay, this value OCF 0. Okay, because timer 0, so that's why we're going to monitor OCF 0. Is it equal to 0? If yes, then it will keep monitoring. If no, what happens? This step number 5, stop the timer, and after that, after you stop the timer, clear the OCF flag, okay, by putting this value. Okay, so you see here TIFR equal to OX02. Okay, if you see here, the value of TIFR is OX02. Okay, why OX02? So this is TIFR 0, 0, 0, 0 for 0 and 2 is 0, 0, 1, 0. Okay, why 0, 0? Okay, why you put a 02 here? Because you see this bit here. Okay, so this bit actually, if you refer to the TIFR register, this bit actually, okay, for this bit is for OCF 0 flags. Okay, so why not we go and see the TIFR? Where is the TIFR? Okay, see this bit. Okay, so this is for OCF 0. So that's why you put the value is 0x02 in order to clear this bit. Ataupun, or if you don't want to use to use that value, okay, you can simply write, okay, TIFR equal, put 1 to OCF 0. Okay, just like that. Okay, so it's actually similar to this coding here. Okay, so this is the explanation. Okay, so step 1, what happened? You load 9 to OCR, and then timer started, and keep monitoring the timer 0. Okay, you see here. Okay. Okay, so the TCNT, so this is the TCNT. The TCNT will keep increase, okay, for each pulses, for each clock pass. Okay, started from 0, 0 because you started with 0. Okay, you clear your TCNT, so that's why it started with 0. And when 0, what happened? OCF remain 0. When TCNT equal to 1, OCF masih lagi remain 0. When the when TCNT equal to OCR 0, which is 9. So what happened here? The OCF, okay, so this is, you need to make correction here. Kat sini OCF sama dengan 1. Okay, and then it will reset back after that. Okay, then after that you stop the timer and clear the flags. Okay, so let's look at this example. Okay, how to write the Ctc mode programming. Okay, again, assume that your register is 8 MHz. Okay, you have a register sama dengan 8 MHz. And you're going to write a program to generate a delay. Okay, you already give you, okay, the delay equal to 25.6 millisecond. Okay, use timer 0 Ctc mode with a prescale of 1, 0 to 4. Okay, so prescale 1, 0 to 4. Okay, so before you do programming part, okay, so what you're going to do here is you need to find out what is the OCR value. Okay, similar what we did in the normal mode. Okay, we need to find out what is the TCNT value, but now we're going to find out what is the OCR value. Okay, how to do that? Okay, sama juga. Okay, first, okay, calculate the T. Since this one here, okay, you have a prescale 1024. So what you're going to do is find the FP, and then after that you get the T. Okay, so 8 megahertz divided with 1024, then what you get? Okay, can you calculate this one?
7812.5.
Okay, sama dengan 7.8125 ya? Kilohertz.
812.5. Hertz.
Oh, hertz.
Oh,
Okay,
kilohertz
sorry.
lah kalau ada 7.7812.5.
Okay, so similar. Okay, you get 7.8125 kilohertz. Right, and then what is the T after you put the F here? Okay, 1 divided by this value. What will you will get?
128 microsecond.
Okay, 128 microsecond. 128 microsecond, or equivalent to 0.128 millisecond. Okay, so this is the T after you consider the prescale option here. Okay, the prescale value. Okay, then step number 2. Okay, so what you're going to do here is you need to calculate delay. Okay, you need to figure out what is the count. Okay, so delay equal to T multiplied with count. Okay, so delay, you already have the delay to 5.6 millisecond, and then T, okay, the period here is 0.128 millisecond. Then you can get your count equivalent to berapa dapat count? Ada 200 clocks there. Okay, so you have 200 times. Okay, so 25.6 millisecond divided by 0.128 millisecond, then you will get 200 times. Okay, then after that, okay, step number 3, or this one we need to use the equation number 4. Okay, so the equation number 4 is, this is for the OCR, because we're going to find out what the OCR value. So OCR equal to, okay, Tcnt minus, plus count minus 1. So this is the formula that you're going to remember for Ctc mode. Okay, then since the Tcnt, okay, we put the Tcnt, we clear the Tcnt. So you can give the Tcnt sama dengan kosong. So OCR is actually equal to count minus 1, which is 200 minus with 1, you will get 199. Okay, so this 199 equivalent, if you convert to hexadecimal, you will get OXC7. Okay, then after that, okay, after we finish calculate the OCR value, then we can proceed with programming part. Okay, so I only focusing on this part here. Okay, kat sini je on the timer programming subroutine. Okay, so this one here, we name it as a void delay 25 millisecond, for example. Okay. Okay, step number 1. What is the step number 1? Clear the Tcnt. Okay, I just put here this thing. Okay, so step number 1, clear Tcnt. Tcnt0 equal to 0. And then step number 2, okay, load the OCR. Okay, since we are using timer 0, okay, we are using the timer 0, so OCR 0 equal to what value that you're going to put? Okay, you can put 199 or you can put the C7. Okay, so 199, I just use the decimal numbers here, so 199. Okay, then step number 3, set the TCCR. Okay, so TCCR 0 sama dengan 0B. Okay, and then 0000. Okay, now we're going to find out what is the remaining value here. Okay, so this is your TCCR. So this is your TCCR 0. Okay, bit 6 and bit 3. Okay, since this one is a Ctc mode, so the value that you need to put here is 0, 1. Okay, so now we have a 1 there. So now we know that this is a Ctc mode. Okay, next, Prescale 1024. Okay, so what is the value for the Prescale 1024? Siapa nak tolong? Who want to help me? Okay, the value for Prescaler 1024. Okay, what is the number that I need to put here at the last 3 bits? Chokna, nak tolong tak Chokna? Do you want to help me? What is the value that we're going to put here?
101.
Okay, it's 101. Thank you, Kelichi. Okay, so 101. Okay, so you refer to the table above. Okay, and then write out this is a 101. Okay, so you know that this is a Ctc mode. And this is prescale of 1024. And then after that, step number 4, okay, monitor the OCF flags. So you just write down Y TIFR and with, okay, just use this data shifting, okay. So OCF 0, because this is a timer 0, and then the one that you're going to look at is flag OCF flags, because this is a Ctc mode. And then is it sama dengan 0? Okay, is it equal to 0? If yes, it will keep monitoring. If no, okay, when the OCF flag is 1, so what happened? Then this is step number 5, stop timer. So TCCR 0 equal to 0. Okay, you already stopped the timer. And after you stop the timer, so what are you going to do? Next, clear the OCF flag. Okay, reset the OCF flag. So how to reset the OCF flag? Okay, so TIFR equal to, okay, put 1 to your OCF bit. Okay, so that's it. Okay, so this is how to generate a delay of 25.6 millisecond using CPU speed of 8 megahertz and with a prescale of 1024. Okay, so we are finished for the timer 0 programming, both for Ctc mode and normal mode. Any question up until here? Okay, before we go more deeper to the timer 2 and timer 1 programming. Ada soalan? Any question from you guys?
Doctor,
Doctor, you go
Yeah.
first. You go first.
the prescale is from is within from 8 to 1024.
Yeah.
Okay.
Okay, so timer 0, okay, the prescale, you have a 4 prescale option. One is 8, followed by 64, 256, and 1024. That's it. Only 4 prescale and available in timer 0.
Okay.
Okay, Amirul. What you want to
Doctor,
ask?
for the program, the void delay, 25 millisecond, is it necessary to put the point?
Oh, no need to put the point because this is only the name. Okay, you can put any names here.
Oh,
Any name you want. Okay, you can put your names also can. Okay, void Amirul. Okay, so every time you call the Amirul means that you're going to generate this delay to 25.6 millisecond.
Okay, I understand that.
Okay, any other question? If no, we're going to proceed for timer 2 programming. Okay, so now we go to timer 2 programming. I resize this one. Okay, make it bigger. Okay, you can see it clearly. All right, so timer 2 programming. Okay, since the timer 2 is an 8-bit Atmega 32. Okay, since the timer 2 is also 8-bit size, so therefore it works same way as your timer 0. So the timer 0 programming is actually equivalent to timer 2 programming. Only that, okay, you just need to change this value here. Okay, this number here. Okay, you need to change this number only. Okay, the way you're going to do the programming is similar. Okay, only change this number from 0. Now you change it to TCNT2. Okay, OCR, OCR2, TCCR, TCCR2, OCF, OCF2, TOV, change it to TOV2. Okay, that's it. This is for timer 2 programming. Okay, and then apart of that, okay, there are two differences between timer 0 and timer 2, okay, which is timer 2 can be used as a real-time counter. Okay, sorry, timer 2 cannot. Okay, so this one is cannot, yeah, cannot be used as a real-time counter. Okay, you cannot do to count an event in timer 2, but timer 0 you can count an event. Okay, remember back timer. Okay, there are two functions of timer. One is to generate the delay, and the second one is to do counter. Okay, to count an event. Timer 0, you can do the delay and you can generate a counter. But timer 2, okay, you cannot do this. Only can generate the delay. Okay. In timer 2, more prescale option can be found. Okay, so the timer 2 have additional prescale option compared to timer 0. Okay, so let's look at this TCCR2 for timer 2, and we're going to focus on this 3-bit here. Okay, the last 3-bit, which is for the prescale option. Okay, you see here in this part. Okay, when you put 000, no clock source, similar. 001, no prescale. 010, you have a prescale 8. Okay, now you have additional prescale 32. Okay, previously we have for timer 0, we have 8, 64. Okay, now you have a 32 in between. And then you have 1 to 8, 256, and the last one is 1024. Okay, so now because you have this additional prescale, now the counter, okay, to count an event now not available in this timer 2 programming. Okay, so I just show you for the timer 0. And timer 0. Okay, so this one here. Okay, you see here, this 2-bit here is used for the counter, but for timer 2, no. Okay, you doesn't have this option anymore because you already have additional 2 prescale option inside of this bit. Okay, so that's why timer 2 cannot do counter. Okay, so that is the difference between timer 0 and timer 2. Okay, the way that you're going to write the program, the way you're going to calculate the TCNT, the OCR value is similar to timer 0. Okay, so that is for timer 2. Okay, now we are going to timer 1 programming. Okay, any question for timer 2? Ada soalan tak for timer 2 before we proceed with timer 1? Okay, if no question, now we proceed with timer 1 programming. Okay. So timer 1 programming. So timer 1 is a 60-bit timer and has lot of capabilities. Okay, so the size of timer 1 is bigger, which is you have 60-bit. It is a 60-bit timer. Okay, so the size of TCNT is 60-bit. Okay, so the timer 1 is a 60-bit timer. Okay, so you can split it into 2 bytes. Okay, because in Atmega 32, okay, our register, okay, the register for Atmega 32 is only 8-bit size. Okay, since this is 60-bit, so you need to have 2 bytes. One is the lower byte, the other one is for higher byte. So that's why timer 1 programming, okay, we can split it into 2 bytes as well, which is TCNT1L for the lower byte. Okay, so this is TCNT. Okay, so TCNT1L and TCNT1H. Okay, so this is your TCNT1. Okay, so this is a TCNT1, in which this TCNT1 is a combination of TCNT1H and TCNT1L. Okay, and then timer 1 has 2 control register. Okay, timer 0 and timer 2 only have one control register, but the special for the timer 1 is it has 2 control register, which is TCCA1A and TCCR1B. Okay, and then TOV1 flag goes high, okay, when overflow occurs, which is similar to timer 0 and timer 2, which is every time the overflow occurs, the TOV flag will be set. And timer 1 has a prescale of 1 without a prescale, 8, 64, 256, and 1024. Okay, now we are going to see this timer 1 programming. Okay, so before that, okay, what about the OCR register? Okay, since the timer 1 have 2 TCCR, okay, 2 setting, okay, TCCR, which is TCCR1A, TCCR1B. So OCR also have 2 OCR, which is OCCR1A and OCCR1B. Okay, so this is the simplified diagram for timer 1. Okay, so first, okay, we look at this here. So this is the TCNT one. Okay, which is it is a 60-bit, a combination of TCNT1L and TCNT1H, and it has 2 TCCR. Okay, one is a TCCR1A and the second one is TCCR1B. Okay, if you use the TCCR1A, means that you're going to use this OCCR1A. Okay, if you do a setting for TCCR1B, means that you're going to use the OCR1B here. Okay, and then for the OCR1, not OCC, OCR saja. Okay, for the OCR1A and OCR1B, also 16-bit wide, so that's why you have a low and high here. Okay, OCR1A low and OCR1A high. Okay, so whenever the TCNT equal to OCR1A, so what happened? The OCF1A flag will go high. Okay, so since if you use the OCR1A as your compare mesh, so now what happened? Okay, you need to look at OCF1A flag. Okay, if you use the OCR1B to do the compare mesh method, so you need to look at OCF1B flags. Right, so this is the general overview for the timer 1. Okay, and then let's look at the TIFR register. So this is the TIFR register that associated with a timer 1. Okay, so this bit here. Okay, so you just focus on this 3 bit here, which is this is OCF1A, and this is OCF1B, and this is for TOV1. Okay, so this is your TIFR. Okay, what about the TCCR? Okay, since you have a TCCR1A and TCCR1B. Tak nampak this one. Okay, so I just open the. Okay, wait, Okay, so this one. Okay, so now, okay, since we have the TCCR1A and TCCR1B, so you need to do setting for both of these things here. Okay, so the bits that you need to emphasize is this bit, okay, on the TCCR1B, which is this last 3 bit. Okay, so this last 3 bit is used to as your Prescale option. Okay, so this is the bit 0, bit 1, and bit 2. Okay, on this side here, okay, inside of your TCCR is used as the Prescale option. Okay, so this is the combination of these 3 bits. Okay, if you put 00, means that there is no clock source. 001, no prescale. 010 divided by 8. Okay, you use a 8 prescaler. 011 64 100, use a 256 prescale. 101 is 1024, and you put this value here. Okay, so this one here, if you're going to use to make your timer as a counter, okay, to count an event. Okay, so this is on this last 3 bit. Okay, and after that, the other bits that you need to know is these 4 bits. Okay, this color here. Okay, this green color. Okay, which is WGM12, WGM13, WGM11, and WGM10. Okay, so I just highlighted the value that you point. Okay, so here, if you're going to use this timer 1 as a normal mode, so the value that you need to put is 0, 0, 0, 0. So this is for normal mode. Okay, if you put 0, 0, 0, 0 kat sini, so means that this is a normal mode. Okay, and if you're going to use the Ctc mode, okay, there are 2 Ctc mode. Okay, one by using the OCR1A, okay, to compare, and another one by using the OCR1B to compare. Okay, you can choose either one. Okay, so most of the time we just focus on OCR1A. Okay, for Ctc mode, okay, so the value that you need to put here is 0, 1, 0, 0. Okay, so 0, 1, 0, 0 on the TCCR part. Okay, TCCR1A part. Okay, and this is by compare with OCR1A. So this is a Ctc mode. Okay, if you're going to compare with OCR1B, also for the Ctc mode, so the value that you need to put here is 1, 1. Okay, so 1, 1, 0, 0. So put 1, 1 at WGM13 and WGM12, while 0, 0 at TCCR1A on WGM10 and WGM11. Okay, so this is a Ctc mode, but using the OCR1B. Okay, you're going to compare with OCR1B. So this is the 3 settings that you need to know for the timer 1 programming. Other than that, you just okay. So by looking at this table here, okay, we can conclude that actually, I put the pen here. Okay, by looking at this table, okay, on this side here, okay, you can see the value at this value is always 0. Okay, so you can assume that, okay, we can conclude that, okay, for the TCCR10, for the TCCR1A, we just set it as 0 in the program because all the value here is 0. Okay, only this value will vary accordingly. Okay, akan berubah according to your setting, which is on the TCCR1. Okay, so you can assume that TCCR1A, okay, always make it 0, and while TCCRB1B, okay, according to the setting. Okay, if you put this, okay, so this is your TCCR1B. Okay, the bit that you need to know here is this bit. Okay, bit 3 and bit 4. Okay, this is where you're going to decide what are the, what we call here, the setting that you're going to use. Okay, which is, if you put a 0, 0 here, means that this is for normal mode. And then when 0, 1, so this is a Ctc, but using the OCR1A. And if you put, just now we put what value here? Yeah, I need to look back on this slide here. Okay, and then if you put 1, 1, okay, so 1, 1, right? If you put 1, 1, this is another Ctc, but okay, compare it with OCR1B register. Okay, so this is the value that you need to know in order to do the setting for normal and Ctc inside TCCR1B. Okay, what about this last bit here? Okay, so this last bit is the Prescale, which is quite similar. Okay, the combination is similar to timer 0 Prescale option. Okay, if you put 0, 0, 0 means that stop timer, 0, 0, 1 no Prescale, 0, 1, 0, which is Prescale 8, until 1, 0, 1 is 1, 0, 2, 4 Prescale. Okay, and okay, so this is the, so in the normal mode, okay, so the value that you need to put is 0, 0, 0, 0 lah. So we just focus on this bit here, all right? For the normal mode, we just focus on this part here, which is this is always 0, okay? On the TCCR1A, we always set it 0. Okay, since this is the timer 1 is a 16-bit, okay, so the TCNT 1 will count out from 0 to FFFF, which is 0 to 65,000. I check what is the FFF. FFFF 65,535. Okay, so this is the total, the maximum that you can count in the TCNT 1. Okay, so similar to the timer 0 and timer 2 programming. Okay, so whenever the rollover occurs, the TOV flag will be set. Okay, so this is the TCNT and this is a time. Okay, when the TCNT increases and it's reached FF, and when it's roll over from FFFF to 0, and what happened? The TOV flag will be rise. Okay, will be set. Okay, for the Ctc mode, okay, again, okay, the setting that you need to put here is 0, 1. Okay, so 0, 1. Make sure that 0, 1 or 1, 1. So most of the time we use the 0, 1. Okay, just compare with the OCR1A register. Okay, for the Ctc mode, the timer count up until the content of the TCNT1 equal to OCR1A. Okay, then what happened? The OCF1A flag will be set. Okay, so this is the TCNT value, this is the time, and this is the setting. Okay, the value that you put to your OCR1A. If the TCNT, okay, the TCNT will increment. Okay, will it be increment until it equal to OCR1A? What happens when equal to OCR1A? Then the OCF1A flag will be set. Okay, and then this will be done periodically. Okay, so this is for the Ctc mode. Okay, now we're going to look at the timer 1 examples. Okay, how to write the timer 1 programming. Okay, the step that you're going to write for the timer 1 programming is similar to the step taken for timer 0 programming, either for the normal mode and Ctc mode. All right, so now you will look at this one here. Assuming that X-stir is 8 megahertz, write a program to toggle port B5 1 per millisecond. Okay, so you have X-stir sama dengan 8 megahertz, and then delay that you're going to generate is 1 per millisecond. So 1 millisecond. Okay, so what are we going to do? Okay, so assume that, okay, so this one here. Okay, so this one they gonna. Okay, so let's do the Ctc mode first, and then after that we do the normal mode. Okay, so this one is Ctc mode timer 1. Okay, so what are you going to do? Okay, based on this information, what you're going to do? Okay, for the Ctc mode, what value that you're going to calculate for the Ctc mode? Anyone? Okay, Ctc mode, what value that you're going to calculate? Ctc mode. Okay, you're going to calculate the OCR value. Okay, OCR, yeah. Right, yes. So we're going to calculate the OCR value. Okay, so yeah, OCR1A, correct? OCR1A. Okay. So now, step number 1, okay, find out the period. Okay, because this one here, no need to use a Prescale. Okay, so we just simply calculate 1 divided with 8 megahertz. You will get 0.125 microsecond. Okay, so this is the T. Okay, next, number 2. Okay, equation 2. Okay, you're going to find out what is the count value. Okay, count delay equal to T multiplied with count. Okay, you have T 0.125 microsecond and delay 1 millisecond. So you can get count. What is the count? 0.125 microsecond divided with 1 millisecond. 1 millisecond divided with 0.125 microseconds, then you will get 8,000 times. Okay, so is it 8,000 times support for the Tcci? Okay, is it 8,000 times is supported on TCNT1 register? Support or not? 8,000 times. Because for the timer 0, okay, the maximum value is 255. What about timer 1? For the TCNT? TCNT1. What is the maximum value for the TCNT1? Okay, 65,535. Okay, since now you're going to have 8,000, so this one is still supported lah. Okay, which is masih lagi inside of this range. Okay, so you can use timer 1 without a prescale option. Right, and then after that, because this is supported, so you just proceed. If not supported, then you need to do some prescale lah. Okay, to choose a prescale value. Okay, number 3. Okay, find out the OCR. So OCR1A equal to TCNT plus count minus 1. Okay, so you have 8,000 minus 1, then you will get 7,999. Okay, so this one here, okay, I advise you, since this is a thousands, okay, so I advise you to change this decimal number to hexadecimal. Okay, please make sure that you change this number to hexadecimal because timer 1 is 16-bit number. Okay, so you need to use hexadecimal. Okay, so when you change to hexadecimal, the value is 1F3F. Is it 1F3F? 7999? 7999. Okay, go. What is the value? 79999. Change to hexadecimal.
1F3F, doctor.
Okay, 1F3F. Thank you. Okay, now after that, okay, we just write the timer programming. Okay, I just focusing on the timer programming. All the what we call here the header initialization. Okay, and the port initialization. I just skip that part. Okay, I just focusing on the timer programming. Okay, so let's this one here. Okay, void. Okay, what needs that you're going to do? Use here. Okay, so void delay, for example, 1ms. Okay, any names you can use here. Okay, so step number 1. Okay, what is the step number 1? For timer
TCR 0 is equal to 0.
Okay, you're going to clear the TCNT. Is it betul? Is it correct? Because this is a Ctc mode, yeah? Okay, the Ctc mode, the first step here you need to do is, okay, clear the TCNT. Okay, so how to clear the TCNT? Okay, since TCNT 1 consists of 2 registers. Okay, one L and the other one TCNT1H. Okay, so you need to clear on both register. Okay, so this is a 0 and this is 0. So this is step number 1. Okay, don't write TCNT. Sorry, TCNT1 sama dengan kosong. Okay, don't write something like this because sometimes the compiler not recognize. Okay, some compiler recognize this one is actually TCNT1L and TCNT1H, but some compiler are not recognize this coding. Okay, so to be safe, okay, we just write down TCNT1L for the low and TCNT1H for the high. Okay, because your TCNT1 is combination of TCNT1L and TCNT1H. All right, next, number 2. Step number 2. What is the step number 2? Okay, you're going to load the OCR value. The other one is for the high. Okay, so you just simply write low and high. Okay, so what will be the value that you're going to put here?
3F.
This is step number 2.
3F and
Okay. Okay, so this is the value for OCR1A, correct? So from here, okay, that's why I advise you to change to hexadecimal, because from this hexadecimal number, you can divide it into low and high byte. So 3F, we go to low, and 1F go to high byte. Okay, so this is step number 2. Okay, what about step number 3? Set TCCR. Okay, you have two TCCR, which is TCCR 1A and second one TCCR 1B. Okay, what will be the value here? Okay, for the 1A, what value are we going to? Okay, we're going to put 0. Okay, always 0. TCCR 1A always 0. Okay, what about TCCR 1B? Okay, so recall back, this is the TCCR 1B. Okay, the bit that you need to set is this bit 3 and bit 4. So this is for the mode setting. Okay, so since this is a Ctc, so what will be the value? 0, 1. Okay, so 0, 1. Why 0, 1? Because we use the 1A and 1, OCR 1A. Okay, we are going to compare with OCR 1A. So that's why the value is 0, 1. What about the last 3 bit here? Do you use any prescale here? No use. Okay, we doesn't use any prescale, so the value is 0, 0, 1. Okay, so you can simply write in binary number or in hexadecimal. So 0B 0, 0, 0, 0 and 1, 0, 0, 1. So you know that this is step number 3, which is Ctc mode no prescale. Okay. This is step number 3. What about step number 4?
Monitor OCF 1A.
Okay, we are going to monitor OCF 1A. Okay, how to monitor OCF 1A? By writing Y TIFR and with, okay, put 1, okay, to this location, OCF 1A, and is it equal to 0? Okay, so this is the value. Okay, if you don't want to use this kind of programming, so the value that you're going to put here, what is the value? If you don't want to use this kind of programming, okay, so we need to figure out OCF1A. So where is OCF1A? So this one. So this is OCF1A. So the value will be 0,0,0,1,0,0,0,0, which is OX10. Okay, so you can replace this with 0x10. Okay, so this is step number 4, monitor. Okay, do the monitoring. And step number 5, stop timer. Okay, to stop timer, you can simply TCCR1A equal to 0 and TCCR1B also equal to 0. Okay, by right, if you write down the TCCR1B equal to 0, it's enough already. Okay, no need to write the TCCR1A. Okay, so this is step number 5. Stop timer. And the last one here, clear the OCF flag. So how to clear the OCF flag? Okay, by writing TIFR Sorry.
Equal
Equal
to 10.
to, okay, OCF1A. Not equal to 10, yeah. If you write down this one here, this is wrong. Okay, if you write something like this is wrong. Unless you put the 0x or this symbol here.
And hexa, Doctor.
Okay, hexa. If you write a hexa number, that is correct. If you not write the hexa number, then it's wrong. Okay, so this one is correct if you put the hexa symbol in front of the number. Okay, so that's it. This is timer 1 programming using a Ctc mode, okay, to generate a delay of 1 millisecond for frequency of 8 megahertz. Okay, so this is the ni lah. Okay, this is the timer settings here. Okay, this is the time. Oh, sorry, this is the programming for the timer, and this is the main program. Okay, to initialize the DDR-B port 5, and this is how to what we call here to do the toggling. Okay, to generate a square wave. Okay, you see here, I just send a 0 first, and then after that I send 1. Okay, and then in between I call the delay. Okay, so do you want to continue with overflow method, or we just make it okay in next week? Do you want to continue, or we just stop here? And for the overflow method, we do it next week, by next week. What say you?